Before you dive too deep into modding or repairing consoles and handhelds, there's one tool that you absolutely need to know inside and out: the digital multimeter. It doesn't matter if you're restoring a Game Boy, diagnosing a GameCube that won't boot, or tracing pads on an N64. This tool is how you see what's really going on in the circuit. Today I'll walk you through the basics of using a multimeter, specifically for console and handheld modding. By the end of this video, you'll feel comfortable measuring voltage, resistance, and continuity. Let's get started. This is my Fluke 17B+. I use it every day for repairs and mods. If you're looking to pick one up, I actually recommend the Fluke 15B+. It's nearly identical, but a little more affordable, and it still gives you Fluke's legendary accuracy and durability. I have a link for the Fluke 15B+ down in the comments below. No matter what brand you get, the basics are all the same. You're going to have a display for readings, a dial for selecting your modes, your probe jacks down here at the bottom, and usually it's going to come with two probes, a red and a black. When you're working on consoles and handhelds, the stuff that we're usually dealing with is very low voltages, safe stuff, 1.8 volts, 3.3 volts, 5 volts, 12 volts. But setup still matters. So when you're attaching your probes, you need to use the correct ports. The ports that we're going to use is the COM port, which is where our ground is going to go. Ground always goes into that COM port. And then we're going to use this one here that's marked for volts, ohms, and then, because mine's a 17, temperature readings. This also has a diode and a capacitance check, but we'll get into that later. You don't want to use these over here unless you're measuring for current. That's what the A stands for. If you're measuring for current, like high power amperage or lower amperage, that's where you'd use these ports. We almost never need to take current readings on the type of work that I do on this channel, but if you feel like you need those and you have questions about it, definitely leave me a comment and let me know. My inspiration for this video, and actually this series of video, comes from two places. One actually is Jay from the Game Chasers. I ran into him at Southeast Game Exchange, and we were talking about I'm starting to create content and want to start kind of building my own thing. And he said, the thing that I never see enough of is very simple, basic, to the point videos on how to use test equipment, how to use troubleshooting equipment. I'm like, frankly, it's a great idea. I think we need more of that on YouTube, less sort of going on and on, even though that's what I'm doing right now, and more getting to the point. The second inspiration for this video is that my multimeter is actually dead. I'm out of batteries. The Fluke digital multimeters run on 2 AA batteries. And if you flip open the back here, the new style multimeters are really nice. You just unlock and you pop the whole top off. Hey, at least it's not Radio Shack batteries. If you don't get that joke, check out my videos. It's in there, I promise. So we're gonna get rid of these Amazon batteries, and I've actually started moving towards rechargeable batteries for things like this, since we're going through it all the time. So I'm gonna throw these in here. Now there's a tab right here that slides up into there, and then these are the other side of your contacts for your batteries. So just sort of cradles in here, press it down, lock it in place. Now, one thing that's interesting is this is also a stand for the meter. So if you're working on your desktop and you need to be able to see it, you can just stand it up like that. I also use it if there's a bundle of wires or something that you're trying to, you can just hang it on that bundle of wires like that, just to make sure the screen's nice and visible for you. And there we go, we're back. AC voltage. Typical AC voltage is this PC power plug. I have it plugged into a power strip here. Now, on most of your alternating current, this has a ground pin. So this is a ground pin here. But on most of your alternating current, it's usually just a hot and a neutral, is what they call it. There's not really a ground when it comes to alternating current. That's why it's symbolized as a sine wave, because it's always alternating between positive and negative. So what you'll notice is that if I take my probes and I go on these top two pins, not including the ground pin here, we're going to get 119 volts, 120 because I'm in the US, right? Now, if I flip the bias of these, so if I put my positive probe in the other side, it's going to give me the same measurement. I'm going to find the connections there. Let's see here. I use smaller probes. There we go. So you notice it doesn't go negative. There is no negative when it comes to AC. So where you put your positive and negative probe doesn't really matter unless you're measuring off that ground probe. Now, the ground probe is kind of nice to know because if we go from ground, which we have now, to the neutral, which we're on now, you see there's not a lot of reading there at all because in most US wiring, ground and neutral are the same bias from your hot, right? So they're not both ground, and don't get them confused, but in this case they're similar. So we'll say that similar is the best way to say it. Now if I go over to my hot from ground, I should get the same 120 volts that we were getting with the other 118 volts. So that is AC measurement. Be very careful working around AC. Be very careful when doing all this. If you don't feel comfortable, don't do it. Research, practice before you get into anything that can hurt you. Most of the stuff we deal with is very low current, low voltage. So it's not something to worry about. However, do be careful. Moving on to the next indication. This is DC voltage. So DC voltage is shown by the dotted and solid line. And what we can do here is actually I can take one of the batteries that we took out of here, and DC voltage does have polarity, it does have bias. So when I go from the positive to the negative, a typical AA battery is 1.5 volts, and look at that one's showing 1.5 volts. So not really sure why I didn't. Maybe the other battery is bad. But if we reverse our polarity, so if I put our black lead on the positive, you see it'll actually tell me it's negative DC voltage. And in some troubleshooting, some power supplies actually have a negative DC voltage output. It's typical in arcades and things like that. On some boards as well, but for the most part, I see them a lot in arcade power supplies. That is DC voltage. If you have something very small, millivolts, you go over to millivolts. We don't deal with anything in millivolts when we're working with consoles and things like that. So the next thing for us is this section right here, and this is our resistance measurement. The resistance measurement is shown by that ohm symbol right there. It looks like a little horseshoe. And resistance is measured across a circuit or across a component. This is a resistor, convenient naming. And to measure this resistor, we're just going to take each lead, touch it to it. And I do know that it's a 150 ohm resistor. There's actually a color code on this resistor that tells us, but I cheated and I pulled it out of a bag that was already labeled. It's 150 ohms. It's measuring perfectly. Resistors are non-biased. It doesn't matter which way you go. We're going to get 150 ohms across it either way. That's measuring resistance. Now, another thing that probably what's most commonly used in digital multimeters is the continuity tester. Okay, so if we hit this one more time, you see the symbol up here right now is on ohms. If I hit this orange button I was talking about earlier, it'll actually switch me over to, I have an audio tone, and it still says ohms. So I'm going to bring this closer to my microphone, and I'm going to touch the two leads together. And when I touch the leads together, that is the sound you get with continuity testing. Now, continuity testing is not the same measurement as resistance. Modern multimeters will give you a resistance reading along with the audio beat, but most of the time when you're using your continuity testing, you're just looking to make sure that your path is working. So if we go back to the resistor that we had, and I put this in line, you'll notice something. there is no audio beep going right now. And you'll also notice that the measurement is slightly different from what we were getting when we were just checking the ohms. It's working its way back down, but what happens is there's circuitry inside of here that it's using for the continuity test, and that can actually add resistance to your path that gives you a not as accurate reading for your ohms. If you need to make a measurement with ohms, make sure that you're set to just ohms, right? Just ohms, because then we go in and it literally just tells us exactly what we're looking for. When we do continuity test, there is no audio beep right now because there's a lot of resistance here between. But you see it kind of starts outside the room and starts working its way back down. But it's not as accurate as it could be the other way. Probably not important for the types of things we're doing and the measurements we're doing. And you'll see me and many people that use multimeters just use the continuity tester all the time. And that's fine, no big deal. The other measurement on this wheel is the diode tester, and that's shown, let's see if we get some focus here, that's shown with that triangle and the plus next to it. We hit the spot one more time, you see we get the diode symbol up there. Now diodes are very unique because they only go one way. The current only passes through one way. One of the most common diodes we deal with are light emitting diodes, or LEDs. If we take the legs of our LED, we're going to see a couple things here. When I hook up each side, see, if I get absolutely nothing, that means I'm reverse biased. That means I don't have my polarities going the right way. This leg is the negative leg, so I need to flip it around. And you can tell too on LEDs, just a little bonus fun fact, the longer leg is the positive leg on LEDs. That's kind of a standard. But then if we want to see here, two things are going to happen. One, my LED is going to light up, which it's very dim. It's running off the batteries inside here, and so it's really not great, but it is slightly lit up. But two, we're seeing that it's passing 1.73 volts through my diode, and that's really the measurement you want to take. Usually when you have things in circuit that you're testing, there'll be a given basically voltage drop through a diode. And then also you want to make sure that it's only one way. You want to make sure that the diode isn't shorted out. If the diode was shorted out, we would get voltage in one direction, and then when we flip it, we would get voltage in the other direction. And this OL means open, which means there's no continuity going through there, which is what we want in a diode. The last thing that we're going to go over on this digital multimeter is this next setting right here, and that is a capacitor tester. There are other devices for testing capacitors, and I'll make future videos on some of those devices that I prefer to use, but if you're in a pinch, the multimeter does a fine job of measuring capacitance. Sometimes it's just not as convenient as some of the other test equipment that's out there. I have a capacitor here, and let's see if we can get in on there. It is a 47 microfarad capacitor, which that's basically how much energy the capacitor can store, and it's rated at 50 volts. So you can't put any more than 50 volts into this. Now, you can put under 50 volts into this all you want. You just cannot exceed that 50 volt value. On the capacitor as well, the longer leg indicates the positive lead. These are polarized too. They do have a bias to them, but some capacitors don't. This one does. It's also marked here on this side. This is the negative side of the capacitor. What I will do is hold this here and hold this here, and we'll see on our meter it starts to charge up, and that's 46.5, and the little u is micro, so microfarads is what we've got there. And that's exactly right. That's at 47 microfarads. That's, pretty close, pretty good. These other settings are for your amperage measurements. If you end up doing any sort of amperage measurements, not something you really need. And this last setting is a temperature measurement, which can come in handy, and that's one of the benefits of a 17B plus is it does come with a temperature probe. There are better ways to measure temperature than using your multimeter, and that's why I recommend the 15B plus, because it is a bit cheaper and it doesn't have this unnecessary measurements needed. And that's all there is to it. So to recap, we covered measuring AC volts, DC volts, ohms, continuity, diode testing, and capacitor testing. If you can master these 6 modes, you'll be ready to troubleshoot almost anything that comes your way in the world of console and handheld modding. Big shout out to Jay from the Game Chasers. If you haven't checked out their videos, I'm going to leave a link in the comment below. I love watching those guys. They hunt all over the place for retro games and toys, and it's really fun watching them go on their adventures. This is my first video in my tools and techniques series that I'm going to start doing. Next time we'll cover another essential tool for your workbench. If this video helped you out, hit like, drop a comment with what you'd want me to cover next, and don't forget to subscribe for more console modding tips.